Hello, this is Ramin. If you watched any of the previous SourceCREATOR introductory videos, welcome back. This is a short video about the one of the biggest advantages of using SourceCREATOR in your projects. So in a previous video, I tried to introduce SourceCREATOR in general and how it can be used, but that was a very long 30-minute video and not very good for a short introduction. So instead of going through all the details, I've decided to use a simple demo that I created using the SDL library to show you the advantages of using SourceCREATOR and how powerful and simple it can be to use SourceCREATOR in your project. So what's SDL? Well, SDL is short for Simple Direct Media Layer. It's a cross-platform development library, as you can see on their website. It's been in development for quite a long time now, and it's a very stable, powerful tool or cross-platform library, if you like, for graphical applications that may use the native graphic system, OpenGL or Direct3D, or other systems on different platforms to run graphical applications. You can see on their website that they've used STL to develop this game, Team Fortress 2. You've probably heard of the game. And STL has also been used in many commercial products, open source products. You might know about the Android emulator. STL is, for example, one of the libraries that enables the Android emulator for Android developers. So I've used this library to create a simple demo to show you how you can, for example, use SourceCREATOR to simplify your life when you use a complex library like STL and create games like Team Fortress. Well, maybe. So let's move on quickly to see what it is that I'm trying to show you. So I have a demo here under a library called STL2 Demo, and these are the components, SourceCREATOR components inside my STL demo. There is a CPP function component, there is a CPP main function component, and there is a CPP program component. Now, these are basically the very basics of a C++ program that I've introduced in a previous introductory video. You can also watch that video later on if you're interested in the details of how these were created. However, just for the purpose of a quick recap, I'll show you how these can be used. I first compile my CPP program into a compiler, a component using my SourceCREATOR compiler. I build CPP function as a component, and I finally build the main function as another component. Now I can use these three to produce a project, a completed program, and I've defined a project called STL Project here. You can see the content of the project. I have instantiated one instance of C++ program that I've just compiled as a component. I've instantiated CPP main function because a C++ program requires a CPP function, a C++ main function. And the way this program works is that I've given it a name. I call program STL2 Demo, and I've also included some documentation here. There is a section, there is a container or an output called documentation, as you can see. And at the end of this project, I've defined the project to contain first the documentation, which comes from lines 4 to 11, and next my C++ program, which is basically defined in the C++ program component. there is an instance of CPP main function, and the fact that we have a C++ program expecting a C++ main function means that the main function produced out of this instance will be automatically fed into the C++ program instance. So we've built all of those, and I just need to build my project now, STL Project, and the project is ready to be used. So let's use the test program and ask sourceCREATOR to produce the STL project. So as you can see, let's run sourceCREATOR STL project again. As you can see, the output looks like this. You have the documentation section, which I had put in the project. Let's have a quick look again as we go through the program. So there is the documentation section, as you can see, output here. And then there is a C++ program, a simple C++ program with a main function. And the way that works is a C++ program defines the structure of a C++ program. This is a component that says we can have global variables, for example. We can have any C++ code placed here and some comment at the top. And as you can see, that's exactly what's happened here. There is a bit of comment at the top. There are the header files included, and there are actually no global variables, as you can see, and then there is the main function, and the main function was defined inside main, like so. The main function is a function in C++ with return type int, with name main, and these parameters, and the body of the function. This looks a little bit more complex than my previous video, but it's fairly simple. The function basically defines a try and catch block to avoid any potential errors or bugs at runtime, and it defines 4 sections inside the try catch block: pre-init, init, post-init, and the main body. And they're all global, which means other components can essentially feed code into these placeholders. So that's how the main function was defined, and as you can see, the output is exactly as we were expecting. There is the try and catch block, and those 4 placeholders have no content at the moment, so this try catch block is empty. So how do we start using this project for producing a STL program? Well, before creating this video, I've created some components that basically make it easier for users of sourceCREATOR to start learning about STL or writing programs using STL. These components are all listed under the names STL underscore, like so. So there are actually 4 components. Let's have a look again. STL function, STL project, STL render, and STL window. Well, STL function is actually just a simple test that I wrote, and we can ignore it. There is nothing interesting in it. I'm not going to use it. STL project is, well, the project that I'm using for this demo that I've just explained to you. It includes documentation and defines the fact that we have to use a C++ program and a C++ main function. So the interesting parts are the window and likewise STL renderer. Now let's not look inside those 2 components, because what we care about here is encapsulation and modularized use of components. That's what sourceCREATOR is really good at. So instead of looking at those components and how they are created, what I'm interested in doing instead is modifying my project and saying that, oh, by the way, I would like to use SDL. Right, this is actually STL20 is actually a component that I forgot to mention. So let's have a look at that. It simply defines some headers and some parts of the main function. So let's see what difference it makes when we use STL2 in our project. We didn't change anything else. All we did was just add a STL2 component, an instance of the STL2 component to our project. Let me make sure that this component is also compiled and available. Next, what I do is I recompile or rebuild my sourceCREATOR project. It's ready to be tested. So, now as you can see, the project is a little bit bigger now. Everything is almost the same, except now we have an additional header file added to our program, and the try-catch block includes some extra source code. And this is all done by just adding one line of code to my project. So let's try that again. I would like to remove this line. I will remove this line. So my project does not use STL. I recompile, rebuild, or maybe I should say recreate the STL project, and I test the project. There is no STL header file included, and the try-catch block is empty. Now I add the line again. I say to my project, to my sourceCREATOR project, that I would like to use STL in my program. So added that one line, recreate my project and test the project again. Now you can see that the STL header file is included and the try-catch block is filled. Now you can learn that in order to use STL, first thing you need to do is using STL init. That initializes the simple direct media library for us to do further interesting stuff. So what else can we do? We had two other components, if you remember. We had the renderer and window components. We didn't look at them. We don't want to look at them. We don't care what's inside them. We're just interested in using them. So that's what I'm about to do. I'm going ahead and adding a window, STL window. Now here is the place where you actually will need some hand, you will need some help, because you might not be 100% sure what kinds of stuff you need to define inside a STL window. Well, hopefully when you receive your sourceCREATOR components, such as this STL window, you will be also receiving some sort of documentation explaining what stuff you can put in them to make them actually useful. So in this case, a window has a name, and this is how you define it. I would like to call it window 001. This is a name used inside the program, and a window may have a title. Although this is optional, I would still like to give it a title. And that is how I have just defined a STL window in my program. Let's try that again and recreate my project and test it again. So you can see that the program is a bit larger. There are no new header files. However, our try-catch block now includes the definitions required for creating a new STL window. we can learn again. If you're not familiar with STL, you can see this is how a new window is created. That view 01 is added here as the title of the window, and you can see that there is a variable name associated with our window. And also don't forget that this variable was added to our program through that new component instantiation. So this line didn't exist before. Now that we have added that line, that one line to our project, it's also defined a variable for us and has actually initialized that variable. So if I try to actually build this program, I can do that. The way to build this program is actually in this demo. You can see this is how you can build the program. If I run this, it will produce a.out, and well, there isn't much happening, but as you can see, there is a success message being printed out, which shows that our STL init went well. That's just what was defined inside our STL components. Now, let's try and make it a bit more interesting, because all we're doing is creating a window and, well, initializing STL, but we're not actually showing the window itself. So maybe adding the renderer is the way forward. What I would like to do next is add a renderer to my project. If you remember, that was another component that we had in our folders. We can use STL renderer, and again, you may not be 100% sure or familiar, or you may not have used STL renderer as a component before, but some sort of documentation would tell you that you must define STL window name, the window that you're going to use. Now in this case, you saw in the program that the window name was STL Window W001. Of course, this last part, W001, comes from our definition up here. I could have called it anything. I could have called it WABC, and then I would have had to change the window associated with our renderer to WABC, like that. So what else can we define, or do we have to define? There is just one other thing that our component requires, and that's the background color. What I would like to do there is to define red to be 0, green to be maximum. I want a green window to be displayed. I want blue to be 0 as well. I don't want any blue in the color, and I want alpha to be maximum, meaning the window is not transparent, it's opaque. So we've defined the background color and a window to be associated with our renderer. Now we expect our C++ program down here to be extended with what is required to render a window using the STL library. So let's do that process again. We regenerate, we recreate our project based on the new definitions, and the project is ready for testing. So you can see there is some extra code added. There is a renderer now. We have a new variable, renderer. It's a very good way of learning actually as well. So you, in order to start rendering with STL, you have to define a variable of type STL renderer, and this is how you have to create your renderer, and this is how you associate a window with your renderer, and the rest is basically trying to display that window for us. Now what I would like to do is to actually run this program. However, something to mention is that previously I tried to build and run the program using this file, STL Project.cpp, but it was left on my disk actually from a previous test that I had done. What I really should be doing is running the test. You see, this is how you run the test, and sending all the output to STL Project.cpp or any file that you wish. Now as you can see, this file is now created and it contains the content of our program. So I can go ahead and build this STL project that I've just generated. A.out would contain the code, and you can't see the window on the screen right now because I'm showing this console on the top, but if I minimize the console and try to run the program, you will be able to see the STL window, view 01, rendered in green. So this is why sourceCREATOR can make your life easier. If you have access to sourceCREATOR, you can define components like these components that I've defined here for my work with the STL library. You can define lots of these components in your project and simplify the maintenance of your code. Or if you're lucky, somebody has previously created a bunch of components for your project, and you can just use those components to easily and simply and quickly develop some prototypes, if not a serious commercial product. Something that you might also be asking yourself is that, well, we've just produced a single file with all that complexity. We just produced a single file by essentially printing the output to a file. How is that going to scale up? How is that going to be any helpful in a large project? Well, there is a lot more to sourceCREATOR than I've just shown you here in a few minutes. For instance, we can actually modify our project and say that we don't want the documentation to go to the same place as everything else. We want the documentation to go to a place called doc.html. And in the same way, we want our C++ program content to be output to a file called new STL file.cpp. So let's save this project. Let's recreate the project. Now we can actually test. Just so that we're sure, I would like to do a list of any file that starts with the phrase new, and as you can see, there is no such file. However, if I run, actually let's try that with also with doc. There is no such file. However, if I run my STL project, okay, the output looks empty. However, if I now try looking for a new STL file, as you can see, that's created. As you can see, the documentation is also produced, and the way those were produced are based on our definition of where the output of these different parts should go. So let's have a look at both of these files. The first file is basically what contains our C++ program, and the second part is the part that we have specified as the documentation. How cool is that? So next time, if you want to build using GCC, the GNU GCC or G++ C++ compilers, we can use the new STL file. We can even specify the output, new.out, right? So I run new.out. Again, let's minimize the console, and you can see that the window has been displayed. So that concludes this video, and thanks for watching. What follows is how to use STL on a Mac. In case you have received or downloaded a package, a sourceCREATOR package, you need to unpack it as explained in the previous introductory video, and you might want to try this STL demo on your platform. And if you're using a Macintosh, by the way, You can run STL on Windows and on Linux. You can run sourceCREATOR compiler on Mac, Linux, and Windows as well. So depending on which platform you use, STL might be different. But here I'm trying to show you how to build STL and run it on your Mac in case you are interested. So first thing you need to do is download and install what's known as the Mercurial, and what it is basically a source control application. You can click on download on their downloads page for your platform, and what comes down will be a complete installer package. You'll use that for installing Mercurial on your platform. Next, you'll have to go to where STL installation documentation is. You can see that using HG, which is Mercurial, this is how you can clone or download the source code for your project, for your STL. And next, what you do is you basically go inside the directory of STL where you've just downloaded the source code for STL. You make a directory there called build. You go inside the build and wait there. If you're on a Mac, on a Macintosh platform, what you need to do is you say cc equals gcc fat.sh. Actually, you need to provide the full complete path to where you just downloaded the source. And from there, you can do /configure to run the configuration and then make. The way that works is I've actually installed it on my platform under the directory work SDL. So you go under build, and from there you can run what I called CC. So this is how you run how you prepare your configuration. CC equals path to where I've just downloaded the STL, build scripts gcc fat.sh. That makes sure you're using the right compiler. I was interested in defining a prefix, but actually this is just specific to Linux. It doesn't have much of an effect on a Mac platform for STL. And once you have done that, you have to run configure. Now I'm not going to run this, it's going to take a very long time to finish. I ran it before and it did work. Next, what I do is I run make. Optionally you can add -j, for example 4, so that your build of the STL goes in parallel using 4 different parallel threads to speed up the work. I ran this before as well. It took a while, but it actually did work. And finally, what you do is once your make is completed successfully, you do sudo make install to install your STL on your platform. If it's a Linux, it will be installed under the prefix, but on a Mac, it actually doesn't work like that. So once that's done, you can see on the STL website that they're recommending you to use this particular way of building your programs. If you call STL config with those parameters, it basically sets up your command line such that your program can link with the STL library that you've just built and installed. Let's run that. STL2 config on its own, you see it's providing the complete set of options for the GNU compiler that I was using. And therefore, this is how we can use STL in our project. Again, I typed G++, which is referring to the GNU compiler. Actually, on some versions of Mac, on newer versions of Mac, this might refer to the Clang or CLang or LLVM compilers from Apple instead of the original GNU compilers, followed by the file name that you've just produced from sourceCREATOR, You can have -o for the output of your compilation, and like we said before, STL2-config, like this would provide G++ with all the parameters required for linking the STL library. If you don't include these, if you actually remove that, you'll get an error saying, well, I could not find STL.h, for example. So that's why we include the configurations like that. And at that point, then your new.out or whatever name you've given to the output will be ready to run. So that's about it. That's how you can test STL demo of sourceCREATOR on your platform.